Network analysis, and of course I have already told you network analysis is part of project management, and in doing network analysis we have to draw network diagram, and I am going to show in this class and explain how a network diagram is drawn. But before that I'm going to explain the difference between different techniques of network analysis, like critical path method and program evaluation and review technique PERT. And also, to start with, first we'll talk about what is network analysis. What is network analysis? We'll talk about a little bit in details what is network analysis. Actually, we'll try to define it. And number two, we'll discuss about the difference between critical path method and program evaluation and review technique. This is the second issue, I'm going to take for discussion. And third, we will discuss rules of drawing network diagram. Or say network analysis, rules of network analysis. Simply rules of network analysis. So these are the three topics to be discussed today's class. First, what is network analysis? The definition part. Second, difference between critical path method and program evaluation and review technique. And third, the most important, the larger part of today's discussion, rules of drawing network diagram, in particular rules of network analysis. First, start with network analysis, the definition part of network analysis. So, what is network analysis? Network analysis is a management technique that's adopted in planning and controlling of complex projects. I told you, network analysis is part of project management. It is a system of planning a project by analyzing different activities associated with it. In network analysis, complex projects are broken down into smaller activities or tasks, which are then organized according to a sequence. So this is very important. We have understood network analysis is part of project management, and to carry out a project, the project managers have to deal with the analysis, network analysis, have to prepare a network diagram before they start the project or before they start managing the project. And what exactly here they have to do? First of all, they have to identify the activities and arrange the activities in a sequence. That's what is said here. In network analysis, complex projects are broken down into smaller activities or tasks, which are then organized to smaller activities, broken down into smaller activities or tasks, which are then broken down, which are then organized according to sequence, according to a sequence, organized, which are organized smaller activities. These activities, the complex projects are broken down into activities, and these activities have to be organized according to a sequence, which must be logical, keeping under consideration the total time and cost involved in completing the project. So this is very important definition or part of understanding network analysis. So let us try to understand what is sequence we are talking about. What kind of sequence? According to a sequence, as I told, organized, these activities are organized according to a sequence, which must be logical. Now, let us say, for example, in a building construction project, you start constructing a building, what first thing you want to do? What first activity you carry out? The first activity is designing the layout of the house. So suppose you are constructing a house. The first thing, for example, designing the layout of the house. And second, what you do, you, according to the plan, you order for materials, order for labor to carry out the work, and you arrange the material and labor. And third, you start laying the foundation of the house. And next, after the foundation is laid, you start laying the pillars. And after the pillars are laid, you carry out casting of roof, casting the roof of the house. And then, once the roof casting is covered, you start raising the walls, raising the 4 walls of the house. And after walls are raised, see, first you laid the foundation, then you laid the pillars, then you casted the roof, and then you raise the walls, and then you start plastering the walls and ceiling and all that. So these are the sequences. As I told, the first was to design the layout of the house, and then according to the design and plan, you order for material, you arrange for materials, stone chips, then rods, cements, sands, all these materials. You arrange for all these materials. Then you arrange the labor work, who will carry out the work, the masons. And then you start laying foundation, and then laying the pillars, then casting roofs and all that. So what I am trying to explain, this is a sequence. You cannot cast the roof, or you cannot lay the pillars until unless the foundation is laid. You cannot start raising the walls until unless foundation is laid. You cannot start plastering the walls. You don't have the walls. So you have to have the walls, 4 walls, and then only you can start plastering. So this is the sequence. You have to follow this sequence. And most of all, you have to arrange materials, you have to arrange the laborers for work, then only you can start work. Until unless you get the material and labor, you cannot start laying the foundation and all that. So all these are happening, all these should be carried out in a particular sequence, one after one. So this is what here is said. These activities, they're all activities. Arranging material, one activity. Arranging labor, another activity. Laying foundation, activity. Raising walls, and before that laying the pillars. Then casting the roof. then raising the walls. These are all individual activities. But remember, see, these activities are happening and should happen in a particular sequence, one after one. You cannot raise the walls before laying the foundation. You cannot cannot cast the roof before the pillars are laid. So here we are talking about this sequence, logical sequence. You have to establish there are different kinds of projects. Project of this building construction, project of pipeline, project of, we'll see what are different types of projects. There are network analysis required. But in any project, any such project, you have to find out the activities involved, and then you have to arrange these activities in a particular logical sequence. That's what is network analysis. So, in network analysis, complex projects are broken down. Into smaller activities, and then these smaller activities are organized according to sequence, which must be logical, keeping under consideration the total time and cost involved in completing the project. This is what network analysis. And to move further, of course, all these analyses should be carried out keeping in mind the expectation of the owners. I mean, the owners who will own the project, they must have some expectation about completion, about cost involved. They will always try to do the project at a minimum possible cost and as early as possible time. When a building is constructed, the owner of the building must always want to finish the completion or the building as early as possible, in a shorter possible time and at a lesser possible cost. At a minimum cost and minimum time, they'll always try to complete the project. That's the owner's expectation. So as a project manager, always keep in mind the expectation of the owners of the project. So all these things you have to keep in mind when you do the network analysis. And next we'll see, in the project management, a network diagram is prepared. I've already told you, a network diagram is prepared whereby all the project activities are represented visually. We'll see how this network diagram is drawn. We have already charted the topics we discussed, and one of them is how the network diagram is drawn. We'll discuss this at length later on. The diagram also establishes the relationship between various tasks, activities of the project. Network analysis ensures that the project is successfully completed. Of course, that's the purpose of network analysis, and that completion should be economically, and I've already told, at a minimum possible cost and much before the expected time. Expected time, it is better to complete the project before expected time. Expected time means expectation of the owner as far so far as completion time is concerned. They always want to complete the project as early as possible, as minimum time involved. So that expectation has to be kept in mind, and while exploring minimum resources. Of course, to reduce the cost, you have to use the minimum possible resources. Resources like in case of building construction, resources are material, labor, and other expenses. So these are the resources. You should ensure that minimum resources are involved in completion of the project, and that also taken care of when you prepare the network diagram, because each activity has time and cost involved. Hence, network analysis reduces operational cost, total time, wastage of resources, and of course conflicts in project management and execution. It means if you draw the network before starting the project, after the project is started, you follow the network diagram and all the details written about the execution of the project is there. So when the execution is carried on, when the project is carried on, there will be no confusion about what to do next or what not to do. There will be no confusion about all these things. But if you don't draw the network before the project is started, there may be confusion in the execution of the project. Some managers, some engineers will say this, some engineers will say no, this is not to be done, this has to be done this way or that way. So there may be a lot of confusion about the ideas and methods of doing the activities between engineers and managers if the network is not in hand before the project is started. So it is better to have the network diagram before you start the project with all the details necessary to execute the during the course of execution of the project. So that is the purpose. So we have understood what is network analysis. To sum up, in network analysis, actually what you do, you break down the complex projects into smaller activities, and then these activities are organized according to logical sequence. And when you organize these activities in logical sequence, you keep in mind the time and cost involved in completion of each activity, as well as in completion of the whole project, entire project. This is network analysis. Our next topic of discussion is, as we mentioned, difference between critical path method and program evaluation review technique. Before we go into that difference between CPM, critical path method, and program PERT, I also want to give you some examples of areas where network analysis is applied. So application of network analysis, where network analysis can be applied, I've already told in construction work particularly. So network analysis is usually applied in the following types of projects, like construction of residential complex, construction of commercial complex, residential complex, commercial complex, petrochemical complex, then shipbuilding, aircrafts, manufacturing, satellites, mission development, installation of pipelines, etc., etc., etc. So these are the projects, and of course many more, where network analysis can be applied and should be applied to carry out the project successfully. Network analysis should be carried out, and of course, as part of network analysis, a network diagram also should have to be drawn. Now, network analysis has different techniques. Number of techniques are there. The most popular techniques are critical path method and program evaluation and review technique, PERT. So these are the most popular and widely used techniques for network analysis. One is critical path method technique, and another is program evaluation and review technique. Let us see the differences between these two. Actually, we'll understand more about these techniques, differences about CPM and PERT when we carry out the larger discussion about how network diagram is drawn. In course of learning the process of drawing network, we'll actually learn more about these differences. But here, to summary, let us see the basic differences. What are the basic differences between CPM and PERT? Of course, the name, critical path method and program evaluation review technique. Second, this critical path method is useful for projects in which the activity durations are known with certainty. What he said, activity durations are known with certainty. Activity durations are known with certainty. This is in case of critical path method. Whereas, in case of program evaluation review technique, PERT, which is useful for analyzing project scheduling problems in which the completion time of different activities and therefore the completion time of the whole project is not certain. So completion time of different activities not certain. Of course, since completion time of activities are not certain, the completion time of the whole project is also not certain. See, as I was explaining about construction project, construction of residential house or building, and I was mentioning about the activities, different activities like procurement of material, arranging labor work, then starting laying foundation, laying pillars. These activities more or less known duration. These activities have more or less known duration, because the project managers and engineers can easily identify, can easily predict the time to be taken for laying foundation, depending on the size of the complex, depending on the size of the building, Depending on size of the project and size of the building, one engineer can easily predict or calculate the time duration to be taken for laying the foundation, time duration needed to lay the pillars, and time duration to raise the walls and all that. So good engineers, any engineers in fact, having experience and knowledge of the subject, they will be able to predict, they will be able to calculate the time duration with certainty. Therefore, these projects are undertaken. Before undertaking these projects, you draw the network as per critical path method. Here the critical path method technique is applied because duration of activities are more or less certain, and that is the reason these projects are called deterministic. And this model, this technique is deterministic in nature. This technique, CPM, critical path method, this technique is deterministic. Why deterministic? Because time durations of activities are known or certain, deterministic in nature, deterministic model. And of course, this technique is used mostly in construction projects. As I was already explaining, mostly used in construction projects. Whereas program evaluation and review technique, since we have already mentioned that this technique is applied when activities, time duration of activities are not certain. You cannot predict exactly how much time an activity will take in course of execution of the project. So this model is probabilistic because you have to apply the probabilities. What is the probability of finishing this activity in so many days? Say, what is the probability of completion of an activity in 9 days? What is the probability of completion of an activity in 12 days? So you have to apply the probabilities because you don't know the exact time or duration to complete an activity before the project is started. And that is why this model is probabilistic model, and this is actually probabilistic in nature. Why probabilistic? I repeat, because time duration of activities are not known with certainty. With certainty, you cannot predict the time duration of activities, and why? That is why it is probabilistic model, probabilistic in nature. And of course, this model cannot be, is not suitable for construction projects. Actually, probabilistic model, program evaluation and review technique model is suitable for those projects where time duration is not known with certainty before the project is started, like research and development project. In research and development project, research and development scientists are appointed, research and development scientists are assigned the job of finding some new formula, job of discovering some new design, or to come out with some new design for a car, design for any product, or formula for any new medicine or new chemical. So to develop, to come out with new designs, new formulas, scientists have to carry out long research work. And still they cannot say, I'll come out with a new design in so many days, in so many months. No, it cannot be predicted. You don't know how much time it will take to come out with positive results. Therefore, activities are carried out without knowing the time it will take to complete. Right? That depends on research work, how research work is going on. To develop new things, you need time. So here, since time duration is not known before the project work is started, we have to apply PERT, program evaluation and review technique. So mostly used, this technique is mostly used in research and development projects. You understood? And last is, of course, CPM, critical path method. The name itself is said critical path method, and that is why you well understand that in this technique, critical activities are differentiated from non-critical activities. Critical activities are differentiated from non-critical activities. Here exactly you know critical activities, which are your critical activities. But in PERT, there is no non-critical or critical activities. You cannot differentiate. This model does not differentiate critical or non-critical activities, because you don't know actually how much time when you draw the network diagram before the project is started, you don't know the time to be taken by different activities. So you cannot find the critical activities because you don't know the time duration. So basically, that is the reason why you cannot differentiate between critical and non-critical activities in case of PERT technique, and in case of critical path method, the name itself suggests you have critical activities and you know exactly which are non-critical activities. You can easily differentiate, identify the critical activities and non-critical activities in case of CPM, and in case of PERT, you cannot differentiate critical and non-critical activities. So we have understood the difference between two important techniques of network analysis, CPM and PERT, critical path method, program evaluation review technique. They are the most important techniques of network analysis. Two topics, and last, the most important, and which will take longer part of our discussion, rules of drawing network diagram, or say rules of network analysis. Let us start understanding the rules of drawing network diagram. So here we go. Network analysis, rules of network construction. A project can be viewed as a set of activities or jobs, also called tasks, operations. Activities, jobs, which are also called tasks or operations, and that are performed in a certain sequence. We have already talked about in details actually this sequence, certain sequence, and determined logically, and we have also discussed about this logical arrangement or logically organizing the sequences when I was discussing about building construction project and different activities. Therefore, the initial step in CPM or PERT project scheduling process is the determination of all specific activities. This is the first thing. I have already told you. The first thing is determination of all specific activities that comprise the project and their independence relationship. Now, what is independence relationship? Interdependence relationship. What is interdependence relationship? Interdependence. One activity is dependent on other activity. Like as I was giving examples of building construction, activity of laying foundation depends on activity of material procurement. How fast, how quickly you can procure material or arrange labor will determine how quickly, how fast you can start laying foundation. Your laying foundation activity will be delayed if your material procurement is delayed, if your arranging labor activity is delayed. Got the point? Your laying foundation and other activities like laying pillars, these activities will get delayed if material procurement is delayed, or say drawing the design itself is delayed. So each activities are interdependent, right? Interdependent, and this is called interdependence relationship. One activity is related to other activity. We will see that in details later on. Until and unless one activity is completed, you cannot start the next activity. Until and unless material procurement activity is complete, you cannot start laying foundation activity. Until and unless laying foundation activity is complete, you cannot start laying the pillars. You cannot start the activity of casting the roof. You cannot start the activity of raising the walls. So, interdependence of relationship has to be established. The first thing is identify the specific activities, determination of all specific activities, and then also understanding the interdependence of this relationship, of these activities. Okay. Once the activities comprising a project and also the interdependency relationship among them are clearly identified. So again, activities and interdependency. These two things. First, identify activities, and second, identify interdependency among activities. So these are to be identified first, and then these activities along with their interdependency relationship can be portrayed graphically by network or arrow diagram. After these activities and interdependence are established, you draw the network diagram, or called portrayed graphically by network or arrow diagram. You will see how this arrow diagram is prepared. Because this project planning function begins with the list of all the activities and the precedence relationship. Precedence relationship means, again, same as interdependence relationship, which activity is predecessor of other activities or which activities are successors of other activities. So predecessor-successor relationship. Interdependence relationship is nothing but predecessor-successor relationship. One activity will have number of predecessors, may have number of successors. So this is precedence relationship. The network can be constructed through the use of series of arrows and nodes. We will know about these two terms, arrows and nodes. Thus, conveniently expressing the sequential nature of the project. Each of the activities that make up project consumes time and resources. Of course, you have to keep in mind this very important point when you draw the network diagram. Each of the activities that make up a project consume time and resources. Time, there is no doubt, each activity consumes time. It needs time to complete. And resources means, as I was telling about material, labor, and of course, if you use a machine, the depreciation of machine, wear and tear of machine, you are using the machine, so some cost of that machine is also involved in the project in the form of depreciation. So there are other expenses also. So these are all resources. Labor, material, particularly main resources are material, labor, and other overheads. So these are resources you consume during carrying out of each activity, of course during completion of the project. So consume time and resources. Definable beginning and ending. Of course, one project has definable beginning, when the project will start and when the project is ending. So you have to show in your network diagram when the project is going to start, exactly when the project is going to start, there is a definable beginning, and in your network diagram you will show when the project is going to end, going to finish. That should be your network diagram showing the starting time and finishing time. The arrows, also called arcs in a network, present the various activities of the project, we have understood. Along with each arrow is given the description and the time estimate of the particular activity it is representing. So we'll see this now. See, this is one small network diagram of a small, very small project maybe. So this is what is called network diagram. Okay. The circles, the beginning, and we're talking about these circles. The circles, the beginning and at the end of arrow, represent the nodes and events of beginning and completion respectively of the activity in question. So what is it? The circles, the beginning and at the end of the arrow represent the nodes or the events of beginning and completion respectively of the activity. So this is one activity and this is node or event, starting node or starting event. This is one node for this activity actually particularly, and of course this node is also starting a node of the entire project. Initial node. This is one node or event. This is called event. Node or event. This is one node, this is one node, this is one node, this is one node. There are 4 nodes or 4 events here, and this is node for this activity as well as for the entire project. And this is node for, this is ending node, finishing node. This is also a node, and this is finishing node or ending node. Now of course ending node for this activity as well as ending node for entire project. Okay. Now come to the rules. One by one we will discuss about the rules of network construction. Some rules are very easy to understand. Just apply your common sense, you'll understand. Some rules are little tricky to understand, little, and I should not say difficult, but you have to apply your mind more about when you need to understand the rules. First, one activity, one arrow. That means one activity, say procurement of material is if one activity. For this activity you will have only one arrow. You cannot say procurement of material with 2 arrows. So one arrow is for procurement of material. So each activity will have one arrow. One activity, one arrow. So as I am saying, each activity will have one arrow. One arrow cannot, similarly, one arrow cannot represent 2 activities. As one activity cannot be represented by 2 arrows, similarly, one arrow cannot represent 2 activities. Understood? One activity cannot be represented by 2 arrows. Similarly, one arrow cannot represent 2 activities. So one activity, one arrow. Next, point number 2, rule number 2. All preceding activities must be completed. Like this. See, here activity D. Activity D has 3 preceding activities. Activity A, activity B, and activity C. Understood? Activity D has 3 preceding activities. Activity A, B, and C. Here again, activity A and activity C are immediately preceding activity of D. Activity A and C are immediately preceding activity of activity D, or you can say immediate predecessor. Activity A and activity C are immediate predecessor of activity D. B is also predecessor, but B is not immediate predecessor. So what you can say, activity A activities A and C are immediate predecessor activities A and C are immediate predecessors of D, right? Whereas B is also predecessor of D, but B is not immediate predecessor. Now, immediate predecessor of D. Now, the important thing to take note of here is preceding activities must be completed. So before activity D started, before the activity D started, you have to complete. The project managers or project executors must ensure that activity A, B, and C are completed. Once activity A, B, and C are completed, then only you can start activity D. So all preceding activities. Therefore, it is said all preceding activities must be completed before an activity can be undertaken, or all earlier activities preceding it must be completed. Thus, a network should be developed on the basis of logical and tactical dependencies between various activities of the project. So fine. So you've understood this. I repeat one important thing here again. Activity D has 3 predecessors. A, B, C. But remember, activity A and C are immediate predecessor of D. B is not immediate predecessor. B is predecessor, but not immediate predecessor. Immediate predecessor is A and B. Okay. Next rule, let us come to the next rule. Here also there is not much complication to understand this rule, only you apply your common sense. Length and shape of the arrow are of no significance. Length of arrows. Suppose when you draw a network diagram, you'll see one arrow maybe of this length and another arrow maybe of this length. But in course of drawing the network diagram, both these arrows may represent the same days, or maybe this may be of 9 days or this may be 5 days. Maybe this is 9 days and maybe this is for 5 days. So there is no relationship or significance of length of there is no significance of length of these arrows. It's not that these arrows should be proportionately less than these arrows in size, because this arrow represent 5 days, this arrow represent 9 days, so this arrow should be in length less than this arrow. No, this is not the case in this network diagram, network drawing. Similarly, shape. So here actually we are drawing a straight line like this, but arrows can be carved also. At some point, at times you see the arrows may be carved also. And meaning nothing exceptional about this carved or straight line arrows. All are same. So there is no special significance of shape and length of the arrows. Understood? Now, rule number 4. Arrowhead marks completion and arrow tail marks start. So this is the start of activity. So our next rule of network diagram, drawing network diagram, so rule number 4. Arrowhead marks completion and arrow tail marks start. So if these are the arrows, the start nodes and ending nodes, this is arrowhead and arrowhead. This head marks arrowhead and this is tail, arrow tail. So arrow tail marks start. Arrow tail marks start and arrowhead marks completion. Head marks completion. This is completion, and arrow tail marks start. Tail, this is an arrow, tail, and this is starting point. That's understood. Tail events and head events. Tail events is the starting event. Head event is ending event. Completion. Head event, completion, and tail event, starting. Then let us understand merge events and burst events. Merge events are a merge event is where a number of activities are merging. This is event number 6. This event number 6 is merge event because 3 activities are merging to this event. Activity number B, C, D are merging to this event. So this is merge event. And burst event This is burst event number 2. Why? Because from this event, 3 activities are emanating or coming out. 3 activities are coming out from this event number 2. That's why it is called burst event. And here, 3 activities are merging to this event. Therefore, it is merge event. Okay? And at this point, remember one thing. In case of merge event E cannot start until and unless BCD is completed or finished. Until and unless activities BCD is completely done, event E cannot be started. This is in case of merge event, where 3 activities are merged into one event number 6, and after that an activity starts, E activity starts. So to start activity E, B, C, D, these activities must be completed. Similarly, in case of burst event number 2 is burst event, and after that there are 3 activities started. 3 activities are emanating from this burst event, B, C, D, these activities. And B, C, D, these activities can be carried out or can be undertaken only once activity is completed. Until and unless activity is completed, B, C, D cannot be started. We have already explained this. Now, rule number 4. Events are identified by numbers. Of course, I have already discussed right now. Events are identified by numbers, like this. Events are identified by numbers. So these are the events. Event 3, event 4, event 5, event 6, event 7, like this. Events are identified by numbers. Activities are identified by I to J, from ith node to jth node. Say one event, say it is 5, event number 5, event number 6, and this is an arrow. So this activity, you can call it activity D, and also D is represented by 5 to 6, like this. I, here I is 5, J is 6, ith node to jth node. So D is also can be represented by 5 5-6, 5 to 6. So I to J. This is how activities are identified. Okay. Now, rule number 8. Activities should have only one initial and terminal node. Of course, very obvious. So nothing special to discuss here about network. Networks should have only one initial and only one terminal node. A network should have only one initial and one terminal node. Next rule is very important. Here it is said parallel activities between 2 events are prohibited. Parallel activities. That means 2 activities joining 2 events. One starting event, one ending event. These 2 events are joined by 2 activities. It's not allowed. Parallel activities between 2 events without intervening events are prohibited. Thus, 2 or more activities cannot be identified by the same beginning or ending events. This is this actually. If you have 2 events, this one event starting event, this is ending event. These 2 events cannot be joined or cannot be related by two parallel activities. Okay, by implication, any two events should not be directly connected to more than one arrow. These two events cannot be connected by two arrows or more than one arrows. This is not allowed or it's prohibited. This kind of network, this kind of drawing in the network is prohibited. You have understood, these are the events. This is one event, this is another event, and these are activities. So these two events cannot be connected by more than one arrows, more than one activities. Under such a situation, actually dummy activities are drawn and help of dummy activities are taken. Dummy activities are needed in construction of network. The dummy activities do not consume any. It's important thing to note of this: dummy activities do not consume time or resources. Zero time, zero resource. Dummy activities are usually shown by arrows with dashed lines, and this is how dummy activities are shown: dashed lines, dotted lines, or you can say dotted lines. Dotted lines or dashed lines. Dummy activities are drawn in a network diagram. So first thing, two events cannot be connected by more than one activities or more than one arrows. This is the first rule about dummies. So in such a case, you have to take help of dummy activities, and dummy activities are those activities which do not consume any time or resource. Now, dummy activities may be of actually two types: identity dummy and logic dummy. Here we are talking about identity dummy. Identity dummies are used when two or more activities have same initial and terminal events. When you take help of dummy activities in this situation, these will be called identity dummies. You'll see how this is taken into account. And logic dummies. Logic dummies are used when two chains of activities have common event. One activity has more than one predecessor, but one common predecessor. This is the case. They are in themselves wholly or partially independent of each other. That's when two or more activities have same, but not all of their inputs in common. The use of logic dummy resolves the problem of representation. So dummy activities, to sum up, that are drawn only to adequately and correctly represent the given precedence relationship, and they are needed when, the case of identity dummy and case of logic dummy. So these dummies are needed when, in case of identity dummy, two or more activities in a project have identical immediate predecessor and successor activity. Two or more activities have immediate predecessor and immediate successor which are identical, same immediate predecessor and same immediate successor. In that case, we take help of identity dummy. When two or more activities have some but not all of their immediate predecessor and activities in common, we take help of logic dummies. We'll understand more about this later part. It may be mentioned here that although the use of dummies provides initially a convenient only a minimum number of dummies as may be needed to draw the network should be used. In a network diagram, number of dummies should be kept as minimum as possible. When you draw a network diagram, number of dummies should be kept under control or as minimum as possible. An efficient network contains a minimum number of dummy activities required to portray the correct precedence relationships between activities of a given project. Thus, while constructing an arrow diagram, the dummy activities may be included liberally, and then the completion of the diagram, the redundant ones are limited. It means when you draw the network diagram, you may take use of dummies number of times or liberally, but once the diagram is complete, you have to eliminate the redundant dummies, which are not necessary. For drawing the network. It's called redundant dummies. You should eliminate the redundant dummies for the network after drawing is over. Now, important rule for dummy activity. A dummy activity will start from the arrowhead of common predecessor and will finish at the arrowhead of uncommon predecessor. Of course, if there is no immediate common successor, or it will finish at the arrow tail of common successor if there is immediate common successor. Now, this rule we will understand better when you take up a particular network diagram and we will draw a network diagram. We will understand this rule better. Last rule of network drawing. Looping is not permitted in network. In network, there should not be any loop activity. This node to this node, again this node. See, this node, suppose here is one node, one node, and come back to the original node. This is called loop. So this kind of looping is not allowed, not permitted in network. Now we will understand how to draw a network using dummies. Let us take up one illustration to understand this. This is one illustration. We will draw a network diagram for this project or this illustration, and we will understand how a network diagram is drawn. There is a manufacturing company has to prepare a design of its latest model of motorcycle. The various activities to be performed to prepare the design are as follows. So various activities are like this. This is the name of the activities: prepare the drawing, carry out cost analysis, carry out financial analysis, manufacturing tools, prepare bill of material, all that. So each of these activities, this is description, and activities are given name like A, B, C, D, like this. And preceding activity. Remember, these preceding activities are actually immediately preceding activity. I repeat, just keep in mind, these activities are immediately preceding. That means B and C are immediately preceding activity of E. C is immediately preceding activity of D. It means D may have other activities also preceding to it. Preceding D, maybe number of activities, but immediately preceding activity is C. C is immediate predecessor. This means C is D's immediate predecessor, whereas A also D's predecessor, B is also D's predecessor, but C is D's immediate predecessor. Clear? Let us try to draw this network. See, hello students. Activity A has no preceding activity. It has no predecessor. So we draw this activity first. Okay. Activity A. It has no predecessor. Now, activity B has predecessor A and activity C also has predecessor A. See, here is B and activity B, and here activity C. And after that, activity D has predecessor C. Activity D has predecessor C. So this is C, and since D has predecessor C, so D must be here. So activity D, it has predecessor C. Then after that, activity E has predecessor B and C. See, activity E has predecessor B and C, and also D also has predecessor C. So D and E both has common predecessor. I repeat, D and E has both common predecessor. The rule is, the dummy here where you have common predecessor, if two activities have common predecessors, one common predecessor out of many predecessors, then the dummy activity should be drawn, and the dummy activity should start from arrowhead of common predecessor and finish at arrowhead of uncommon predecessor. So D and E, they have common predecessor C, and B is uncommon predecessor. So dummy activity should start on arrowhead of common predecessor and end on finish at arrowhead of uncommon predecessor, that is B, right? D and E. So let us draw the dummy activity starting from arrowhead of common predecessor, the dotted lines, and finishing at uncommon predecessor. Now you see, D has only one predecessor, immediate predecessor C, whereas E, if you draw now E, this is E, you will see this activity E has two predecessors, B and C. B is direct predecessor and C is predecessor via dummy. So E has two predecessors. B and C. B is the direct predecessor and C is through dummy. Whereas D has only one predecessor, immediate predecessor. D has only one immediate predecessor, C. Okay. Now come to F. Here again you see F and G. In case of F and G, they have common predecessor E and uncommon predecessor D. That means here again you need to have a dummy activity, and here again dummy activity will start from common predecessor and end on uncommon predecessor. Here common predecessor is, so far as F and G is concerned, common predecessor is E and uncommon predecessor is D. So dummy activity will start from common predecessor E and end with uncommon predecessor D. This is the uncommon predecessor so far as these two activities are concerned, E, F and G. For F and G, E is common predecessor, D is uncommon predecessor. So start from E, arrowhead of E, and end on the arrowhead of uncommon predecessor. The D is uncommon predecessor here, so finish here. This dummy activity will finish here. Start here and end here. Okay. Now F has two predecessors, D and E. D and E via dummy. So here must be F. This activity must be F. because F has two predecessors D and E. D direct predecessor, immediate predecessor, and E via dummy. And G has only one predecessor, immediate predecessor E. So let us see, we have G here. This is G. So this activity G has immediate predecessor E. G immediate predecessor E. So G has immediate predecessor E. F has two immediate predecessor. One is D directly and another is E through dummy. Now after F and G, H has immediate predecessor G. So you take here H has immediate predecessor G. Okay. Then I has immediate predecessor F. So this is F. So this must be I. So I has immediate predecessor F. Okay, clear? H has immediate predecessor G and I has immediate predecessor F. After that, J has two predecessors, I and H. So I and H, these are the predecessors of J. So obviously there must be one activity here which is J. So J is one activity which has two immediate predecessors I and H. J has immediate predecessor I and H. And finally, last activity is K, which has only one immediate predecessor J. So this is K. K is the last activity. K is the last activity which has only one predecessor, immediate predecessor J. So this is network diagram. This is network diagram for this project, where you have how many activities? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have 11 activities and events 1, 2, 3. You can name the events. You can name the events. So event, actually when you write the name of the event, 1, this is node number 2, and the node 3, node 3, 4, 5, 6, 7, 8, 9, 10, 11. Nodes and dummies, including dummy activities, number of activities, total number of activities 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 activities including 2 dummy activities. So we have understood how network diagram is drawn. So students, so far as network analysis is concerned, we have understood 3 things today. We have understood three things today. Network analysis. Regarding network analysis, what is network analysis? We have understood what is network analysis, the definition part, and we have understood the difference between critical path method and program evaluation review technique, the two important techniques of network analysis, and also we have understood rules of drawing network diagram, that means rules of network analysis. So that's all in this class. If you like this video, please press the like button and subscribe my channel. Please subscribe my channel and press the like button. Thank you very much. Thank you.